Greetings, welcome to the course on Operations Research Technique. Students, we are now presently in unit number 1, linear programming problems. In this, we have seen various aspects, formulation of the linear programming problem from given data, mathematical formulation of the model, and also studied graphical method for finding solution to the linear programming problem. We have seen the limitation of graphical method for finding solution to linear programming problem. In that, we have discussed it is only suitable for two variable problem. If problem has more than two variables, then graphical method of finding solution to LPP fails, because on graph paper, since it is 2D, we have only two axes, x1 and x2. If problem has more than two variables, let us say 3, 4 or n number of variables, we cannot solve that problem by graphical method. And therefore, if you remember, in last lecture we have discussed other method for finding solution to linear programming problem, which we have referred as analytical method, or other name to the method as Simplex method. So if you recall our last lecture's discussion, we have discussed this aspect, what is the Simplex method, where it is suitable, and also I have discussed various aspects of various steps when we are applying Simplex method, how to proceed. And at last juncture, we have seen this particular slide wherein we have said that we will solve this problem by Simplex method. Now it is very sure, if you look to the mathematical version of this problem, here you are having how many variables? So you can note here, you are having here three variables. Which three variable? First is x1, second is x2, third is x3. Means definitely graphical method is not suitable for this particular problem. Got it? So here no option other than to go for the method, analytical method, referred or called as Simplex method. It is very clear now. So what we have studied under steps in previous lectures is this formulation, given formulation is referred as, this formulation is in, I have discussed, is in canonical form. This particular mathematical version is in canonical form. And if you remember, I have said we have to convert this into standard form. So canonical form formulation to be converted into standard form before you proceed for finding its solution by Simplex method. So this is the very first step, and we have seen that in canonical form we are having basically three types of in equation. One is say greater than equal to, other is less than equal to, and third variety is equal to. And if you remember, we have discussed how to convert this greater than equal to or less than equal to or equal to into standard form. So let us write here before proceeding. Now what we will do to understand, what we will do is we will convert this into standard form. So remember, when you go for converting into standard form, we will not write first directly the objective function equation. First what we will do, we will keep its space as it is, and then I will write. So here I will write what I am doing, converting into standard form, converting the given canonical form into standard form. This is first requirement. In that we know that objective function is maximize z. Now I am not writing this at first point. I will make it clear why I am not writing this in the beginning. What we will do? We will write this constraint subject to. Now this is very important. Subject to, see here, first equation 2x1 plus 3x2 less than equal to 8. So we have seen how to treat this particular equation. Whenever it is less than equal to, you have to add slack. Because this side is deficit. So as discussed, what we will be doing? We will be adding slack. So 2x1 plus other term is 3x2. Now something is slack. The slack is represented by s. We are adding it for the first time. Therefore suffix 1. Now this left hand side is equal to right hand side, which is equal to 8. This we have studied under the steps version in last lecture. Second, in the similar fashion, can be written as 2x2 plus 5x3. Again I have to add slack. I am using that slack second time. S I am using second time. Therefore S2. Now this is balance equal to 10. In the same fashion, third equation will be 3x1 plus 2x2 plus 4x3. Again slack, so add S3, which is equal to 15. So these are the three equations now in standard form, which earlier were in this inequation, that is canonical form. Now we know that we are not interested in the value of S. We are only interested in the value of x1, x2, x3 as a solution to this problem. These S, S1, S2, S3 are fictitious variables. They are not in existence. Like dummy, we can say they are like dummy. When we are not producing, when we are not having any value, any quantity of S slack, that is S1 and S2 and S3, so the profit coefficient associated with these variables, fictitious variables, will be 0. Mind well, it will be 0, which is to be considered in objective function. So now I will write objective function. See here, originally we will write 3x1 plus 5x2 plus 4x3. This is original. You have created to solve the problem S. Now you know that the profit associated with S, since it is not being actually produced, will be 0. So 0 into S1. Similarly 0 into S2. Similarly 0 into S3. So what will be the net effect of this S1, S2 and S3 in the objective function? Maximize, suppose it is profit, will be 0 multiplied by any quantity will yield 0. 0 plus 0 plus 0, total will be 0. And if you add all these 0 into this 3x1 plus 5x2 plus 4x3, it is the original maximize equation. So even if you convert it into standard form, there is no harm to objective function in standard form. Now we have seen, unless and until we write non-negativity condition, the problem is meaningless. So we have to write here where x1, x2 x3. Now these three variables s1, s2, s3, all these 6 variables are now greater than equal to 0. This is standard form of this version. So this is the very first step. Remember, students, you have to remember, this is the very first step if you are intending to solve problem by simplex method. So what is the step? You have to convert problem structure into standard form by various steps discussed in previous lecture, and tabular notations are given how to treat, and we have applied those logic to convert canonical form into standard form like this case. I think this is very clear now. Once we are ready with this, we can now proceed further for finding, or we can say algorithm wise improving algorithm step by step, and we will reach to final optimal algorithm where that algorithm will terminate and we will get final solution to the problem. So as discussed in the last lecture, LPP deals with real life solution, and if you recall my sentences in last few lectures, I am repeatedly telling you that LP deals with real life situation, means whatever we are producing, either it will be 0 or some positive quantity. You cannot get minus production. Minus means you cannot get minus variables. So to start with, how we proceed, putting or substituting, you can write x1 equal to x2, you are getting this, equal to x3, all 3 equal to 0. Very important, x3, all 3 equal to 0, means the value of x1 equal to 0, value of x2 equal to 0, value of x3 equal to 0. If I put these values equal to 0 in the standard form equation, initial solution to simplex, that is first solution which I am getting is, if you put x1 equal to 0, if you put x2 equal to 0, first equation leads s1 is equal to 8. Similarly, if you put x2, x3 0, second equation leads s2 equal to 10. And if you put all these 3 variables 0, third equation yield s3 equal to 15. So students, what I am putting in this block, s1, s2, s3, these are the first solution variables of this simplex process which we are applying to this problem. So the first solution which we are getting, remember what I am saying, the first solution which we are getting for simplex method to this problem is produce, if it is related to produce, s1 equal to 8, s2 equal to 10, s3 equal to 15. Mind well, I am again repeatedly saying, I am not interested in values of s1, s2, s3. I am only interested in the values of which variable? x1, x2 and x3. But to begin with, since we are starting from very scratch, what is scratch? all decision variable 0. All decision variable 0. If you substitute all decision variable 0, this is your initial feasible solution. I mean first solution which you get for this problem under simplex method. And now from this scratch solution we will move step by step ahead towards optimal solution. This as a base, we will use this as a base and we will move step by step by step by step upwards to get optimal solution. Now here you can get, also find, if I put these values over here, suppose what will be the objective function with these S1, S2, S3 existing as 8, 10, 15. You can see here 3 into x1, putting x1, x2, 0. So this real variable term will yield 0. 0 multiplied by fictitious variable term S1, S2, S3. This will also yield 0. And initial solution, initial objective function answer, first step objective function answer for this problem will be maximize 0 with S1, S2, S3 as the variables. But this, we are not interested in this. Now we will go ahead. So we will follow the methods we have discussed in previous problem. Now what we have to keep in mind, our value of S1 is 8, S2 is 10, S3 is 15. We have to remember this and we will go to the next slide. So in next slide, if you recall, so remember these values 8, 10, 15. 8, 10, 15. So now I have shown you in previous slide how you have arrived at this point. So from previous discussion, what you can find is बंद कर